YouTube streaming now. Um, just looking at the time. I was leaving another meeting, a union meeting, and the focus was mostly on how are classes going to be taught in fall 2021. Now, in computer science, it's not as big of an issue, because we can always teach online, even though, there are many professors thinking that teaching online is not going to be nearly as effective as teaching face to face, but it is doable. But then there are classes in photography, in welding, in automotive repair. Those classes are really difficult to teach online, and most of the time it is not possible. So as a result, there will be some people who have to teach online, and it is an issue for those professors because, how do we make sure that they are safe? Yeah, public speaking is interesting because technically it is doable online, um, even though it's not the best medium to teach those classes. But technically, it is sort of online capable because we know that politicians, continue to be politicians even though they have to do everything online, or most of the things online. They are not completely online. But we know comedians, okay, Entertainment Tonight, those are all being done quote unquote online, meaning that the hosts are not going to a studio anymore, so they're all at home, you know, in casual clothing and stuff like that. So that's kind of interesting. I don't watch a whole lot of TV, so you know when I saw that, it was like, oh, I didn't know people were doing that now. Yeah, yeah, it's definitely not the same. I agree with Rachel. It is not the same, but it's also not as impossible as teaching a welding class. So there's that. Yeah, you can kind of imagine, in a welding class, because in certain PE classes, you can even kind of tell students to do certain exercises at home, um, you know, but in a welding class, it is really hard for people to get their own welding equipment and use it safely at home too. So that kind of raises, interesting issues to say the least. All right, so what we'll do today is we're going to go through the practice exam today. Okay, so that's kind of our goal for today. All right, so let me go back to the test. There we go. So this is, nope, this is not for us. This is for my other class for CISP 440. And the one for this class, okay, just give me a second here. I will bring it up really quickly. All right, so let's see. So I'm hoping that you guys have downloaded that already, um, and then you can look at all your own copy and also take your own notes too. Okay, I think that is actually an important part of this class is to take your own notes. Even though everything is getting recorded, I think it is still going to be useful if you write down your thoughts, on your own document. All right, so there we go. And let me put it into the viewable area, of this class. So the first part, the instructions, there should be no big surprises. Everything is kind of as you would expect from an exam. Okay, so I was just reading the chat channel to see what I've been missing. So the test is going to be an individual exam, no collaboration, and because this is a synchronous class, the entire class is going to take the exam at exactly the same time, which is going to be 5:30 p.m. That's the starting time, and it's going to be ending at 6:50 p.m. and the date is next Thursday, which is the 25th. So that's when we are gonna have our exam one. So instead of having a flexible schedule for people to sign up different time slots, because the class is synchronous, so we are all gonna take the class at exactly the same time. I have been thinking about, okay, there's no guarantee that I may or may not do this. I've been thinking about sectioning the 80 minutes into subsections too. So the first quarter would be on certain questions. The second quarter will be on other questions. So I will break it up further into smaller portions. So there'll be time limitations of when a particular question can be answered, and that would apply universally to the entire class. So I've been thinking about it. I haven't decided on it yet. Okay, I know the impact there can be some impacts because of that. Yes, that would be stressful. Yes, it will be very ridiculously stressful, but hopefully it is going to be exactly the same stressfulness to everybody. So there's still it's still fair, okay, from the sense that it is equally stressful to everybody. But I don't want you guys to be super stressed out. Um, my concern from my side is academic integrity. So I don't want to overdo things either. For the sake of academic integrity, I don't want everybody in class to be suffering because of that. So I kind of have to evaluate what to do with that. Um, but thank you for letting me know that if I did that, it would be uh, super stressful, and I understand that too. I was a student once. That was a long time ago, but I was a student once. So getting to the questions that we have today. Okay, so this is the fun stuff that we're gonna do today. So we got a few questions that are of similar nature, but not exactly equal. Because if you look at question number 1, 2, and 3, some of these have more question marks, and toward the end, you will see there are more spelled out values. Like question number 5 definitely has more zeros and ones already spelled out, so that makes it easier. Okay. And then if you go all the way to the last one in question number 8 of 8, that should be the easiest of all the questions. And in all of these questions, the question mark should be replaced by just either a 1 or a 0. Cannot be both. There should be no flexibility that it can be either. So there's only one way to decide it. So let me ask you guys a question. Do you want me to start from the bottom, which are the easiest questions, and then back up to the top, which are the hardest one, or do you want me to work on the hardest one and then to the easier ones? All right, so I'm just looking at. Okay, so most people say you'll work on the start with the harder ones, except for Eric. Okay, all right, and also Alfred. So some people want to build up. How about this? I'll alternate. Okay, we'll start with number 8, then go back to question number 1, and then question number 7, then question number 2, and so on. Okay, so that's all right. So we'll start with question number 8 first. Okay, because that's the easier one, and I'm going to do this on the tablet, so this way I can actually um, draw stuff, so that kind of in a free form way, which is kind of important when I have to work on questions like these. Oh, the last question is super duper easy. Or not. Okay. Alright, so almost there. Okay, so we got Q, T, and then D. There we go. Alright, so let me switch to the tablet. There we go. Alright, so this is question number 8. So question number 8 is super easy to answer, because most of the bits are already spelled out. Okay, but I will still use the non-intuitive approach to do this, because most people would say, oh, since x and y are both given, we can just kind of work our way down here. Let's assume that is not the case. Okay, so we'll basically have to find out which question mark are we going to resolve first. The Q's are the ones are very easy to resolve. Given that we have X and Y available, Q is easy. So the first thing we need to do to answer these questions is to have all the definitions handy, you know, especially when you're in the exam. Okay. So since we're only practicing, I'm just gonna spell out some of the rules. So Q of I is X of I exclusive OR with Y of I. That's really just how Q is defined. So in this case, we can tell, oh, okay, that means, we have the two spots for Q's, they are ready to be resolved at this point. 0 exclusive OR with 0 is 0, 0 exclusive OR with 0 is 0. We also know that the D bit is also just the exclusive OR between the QI and the TI. So that means we can resolve at least one of them, okay, right? Because this one here, we can resolve already because we know 0 exclusive or with something is a 0. The only thing you can exclusive or with 0 that would give you a 0 is 0 itself. So that one is now resolved. Um, so now we have to figure out the T bits, right? The T bits are the harder ones to figure out, but they're also more informed. Okay, they will give us more information. The one T bit that definitely can be resolved is the last one, or T4 in this case, because 0 minus 0 does not give us a borrow of 1, 0 minus 0 does not give us a borrow of 1, so this has to be a 0. It is like Sudoku. Yes, you're absolutely right. It's kind of like a Sudoku or crossword puzzle, but using rules that we have already talked about in binary subtraction. Yep. Yes, that's exactly what people said last semester. All right, so now we look at, now you have to kind of remember the T0 is not necessarily a 0, okay? So that assumption may not be applicable, okay? So we don't know whether this is a 0 or 1, which means we cannot tell what this bit is going to be, nor what this bit is going to be. So now the question is, at this point, where do we go? Even though it looks simple, it is not really that simple because we cannot assume T0 to be 0. So now we look at this borrow bit here, okay? This borrow bit, which is T3. So we know T3 is a 0. What does that mean, right? So if T3 is a 0, that implies the B of x2, y2 has to be a 0, and the B between Q2, T2 also needs to be a 0. Does that make sense? Because if at least one of these two is a 1, then we would end up T3 being a 1. So, but because we already know T3 is a 0, that means the borrow of the subtraction between y2 x2 y2 and the borrow and also the subtraction between q2 and t2, neither of those subtraction will give us a borrow of 1. All right, so we got a few people typing, and I'll kind of wait a little bit as I drink some coffee. I had a 1 hour and a half meeting before class, so that's why I have a pretty big can of coffee today. All right, so there's a question of, can I write the equation for Ti on the side? I have mixed feelings about that because first of all, it is definitely in the modules, right? And then two, I'm kind of expecting people to know that by now, even without having to refer to the modules. Um, and Douglas is mentioning, yes, so you need to kind of explain the reasoning. And if you're using the same reasoning for several bits, and it's like, okay, I'm using the same technique as the other one, you can just kind of say refer to the other one. But it still needs to be some sort of reasoning to let me know how a particular bit is resolved. Um, So to answer Jonathan's question, I am not going to write it, okay? But I will tell you where to find it. I'll give you the next best thing, which is to tell you where to find it. Because okay, excellent. Thank you. Yeah, so this is why studying and coming up with your own list of all of the definitions is going to be important. Okay, because the those rules is what is going to give you the constraints so that you can tell whether something has to be a 0 or 1. Okay, so that is important. So as you're studying for next Thursday, I highly recommend that you kind of jot down all of the definitions into one spot so it's easy for you to look it up. How do we get T2 and T3 being 0? We don't know whether T. Oh, so the original question is this. Okay, and we found that Q2 is a 0. So the first one that we resolved was Q2. So Q2 is a 0 because of how Qi is defined, and both x2, y2 are given already. So that's how T2. That's how we determine T2 is a 0. Um, no, I take it back. That's how we determine Q2 is a 0. Okay, so Q2 is a 0 is first determined like that. And then the next thing we determine is T2. So T2 is a 0 because we know D2 is a 0. Because D2 is a 0 and Q2 is a 0. That's how we can determine T2 is a 0. Does that make sense? Because we are asking the question of, what can exclusive OR with 0 to end up with a 0, and the answer is there's only one possible thing, which is 0 itself. So that's how we can resolve that. All right, so now that we have confirmed this is not T3, this is actually T2. So now that we have confirmed the T2 is a 0, how is it going to help us to determine, the ones, right, the bit ones? So I have to readjust all of these as ones. Okay. All right. So T2 is a 0 means, the borrow between x1, y1 has to be a 0, and the borrow between q1, t1 also has to be a 0. That part has to do with how T2 is defined based on the bits of based on bit 1. Okay, the entire column of bit 1. All right. Knowing that the borrow of x1, y1 is a 0 is not going to help us because we already know that is a 0. This is already determined because x1 is a 0, y1 is already a 0, so we already know that is not going to contribute a borrow of 0. But then the next one is going to be helpful because q1 is already a 0 to this is a given. Okay, that is a given. So now we are asking what can the value of t1 be so that we do not end up with a borrow of 1? That is the question, right? So now you have to look up the definition of the b function. So the b function, the b of xy is not xy. So that means, if q1 is a 0, there is a chance that we might end up with a borrow if t1 is a 1. But since we know that the borrow of q1 t1 has to be a 0, so that means we have just locked down that t1 also needs to be a 0. So now we say, okay, this has to be a 0. Now I didn't write down the explanation on the side, because that's going to take a little bit of time, and I don't want to spend the time because Q1 is going to take even more time to explain. But I'm explaining everything in words just so that you can hear that, and then if you want to take notes, you can do that after the class. You can kind of go back to the video recording and then pause, jot down some notes, and then unpause and then jot down some additional notes. There are really only a few key things that you need to know. Okay, after that it's just a whole lot of reapplication of stuff. So now that we know Q 1 is a 0, t1 is a 0, we can also now determine that t1 is a 0. That really just has to do with how d is computed, computed from the q and the t of the same column. So there is that. So now we have to kind of go backward again and say, how did we end up with this 0 over here? It has to be a 0, but what is the implication of t1 being a 0? Now we can tell that 1 minus 1 does not give us a borrow of 1. Okay, so 1 minus 1 is consistent with an overall borrow of a 0. That's fine. But we also now have to say, what about q0 minus t0? It potentially can give us a borrow of 1. It doesn't give us a borrow of 1 only because t0 has to be a 0. So this is how we can lock down t0 and say it has to be a 0. Okay? And now that we know t0 is a 0, we know q0 is a 0, t0 is a 0. So now we can also just say, d0 also, needs to be a 0. So that's the kind of reasoning that I apply to answer question number 8. And question number 8 is easier to answer only because a lot of the bits are already supplied. Do we have any questions about number 8?
Can you hear me?
Yes, I can.
Okay, so in general,
hmm
do you want us to write out this explanation with like equations, or could we just explain it pretty much how you did, just to explain our work, if you know what I mean?
You kind of have to explain it to the point where it references um, the equations, the definitions,
Okay,
and the equations, and make use of whatever is already available, already is determined at that point in time.
okay.
So you have
So
to
so
kind of make, yeah, you have to make the connections so that I can see how you reason out whether something needs to be a 0 or a 1.
gotcha. Okay, thank
hmm
you.
And Chris is correct. But because you can reapply the same technique over and over again, you can just kind of label a particular technique and say, okay, I'm reapplying that technique that I have already explained in details. And this is the same scenario, and therefore I apply the same technique, and then I can determine this bit is a 0 or 1. hmm All right, cool.
I did have one question about the T0 bit.
Yeah,
Um, if I re- if I remember correctly, that is the one that we do normally assume that to be zero, correct?
that is correct. We can normally assume it is 0, but not in this exam. Because
Gotcha.
because in the carry look ahead adder, T0, not in that case, it's called K0 in that one, but it served exactly the same purpose. But it's one of the input pins. So that's why in this test, T0 cannot be assumed to be 0.
Gotcha. So we're just proving why it's zero this
Correct.
time, right?
Right,
Gotcha.
but it may be
I see.
1. In certain questions, it may be a 1. T0 can be a 1
Okay.
because
Okay.
it's
Thank
one
you.
of the inputs. All right, cool. Oh, I forgot the other bits too, because you also have to look at the overflow bit. So the overflow bit is defined as the most significant bit of x. So it will be x2, not y2, not d2, or not x2, y2, d2. So in this case, once we have resolved all of these columns, we can see that the overflow is going to be a 0. I believe the sign bit is also one of them. So the sign bit is really just the most significant bit of D. In this case, it's D2, and since D2 is already resolved here, it's also a 0. So don't forget the flags, because the question, these questions also ask about the flags. All right. Okay, so to answer Jonathan's question in the text channel, the HTML document was uploaded as a Google Doc. So you basically just write your answer in Google Doc under the question. that was the arrangement from last semester. All right, so oh, right, there are additional parts. Thank you, Jackie. I will get to that. Um, that's the L bit. The what looks like a 1 is the L bit. So the L bit is the overflow exclusive OR with the sign. So in this particular case, the L bit would also be a 0. So it looks like a 1, but it is really an L. Yep, there we go. All right, so let's go to the other parts of the question. The other parts of the question, second part is the signed versus unsigned interpretations of x, y, and d. All right, so let's do that first. So that's fairly easy in this case. So the unsigned value of x is basically just 1, and it is basically 1 times 2 to the power of 0, which turns out to be 1. Same thing for y, and then for d it's super easy, right? Because there's nothing. Okay, there's no digit of 1 in d, so the unsigned value of d is just 0. And then the signed version is the same thing. So the signed version of x is also just 2 to the power 0, which is 1. Y is the same way. And then d is 0 because of exactly the same reason. That's because the sign bit is a 0 for all of these rows. Okay, but when we get to a particular question where we have the most significant bit being a 1, then you have to kind of tell me why it is a negative value. What formula do you apply to tell me that it is a negative value? All right, so Luke has posted a question. So if we have q0 equals to x0 exclusive or y0, q equals to 1 exclusive 1, then we can just say q1 is 1. Hmm. I'm I'm still looking. I'm still reading Luke's question. So Q is already okay. So the equation tells us how Q is defined, and then the next one Q equals 1 exclusive or with 0. Oh, okay. Yes, yes. So you can just refer to so you can refer to the general equation of Qi equals to Xi exclusive or with Yi. So that way you can just say, okay, it's just that rule that I'm applying. And then Sasha's question is, what is the signed bit equation? That is in the binary comparison module. So if you go to the binary comparison module, you will find the expression to compute the value, the signed value represented by a bit pattern. That is where you find it. So I can definitely recommend people uh, to read the modules carefully. So it's the binary numbers comparison one, and it is one of the sigma formulae. So it's the sign interpretation. It's this one here. This is how you can find the signed value of a bit pattern x. It's this particular formula here. So this is the answer to Sasha's question. So I'm showing you guys where to find it instead of just quoting it in today's lecture, because I think you guys really need to read the notes to the point where you know or you have extracted all of these definitions into a condensed version of all of these formulae and equations. So that's kind of important. All right, so Luke is asking, can't we use your minus C2 of 0, 1, 1, 1? I'm not really quite sure about what that means because we don't have a 0111 in our current question. Alright, Alfred is asking, is the entire test just binary subtraction? That was the previous one. This is all that it is, okay? The fact is this is what I did last semester. But the scope of your exam is including everything up to and including signed versus unsigned representation, the carry look ahead or the borrow look ahead mechanisms, and so on. Um, Sasha asks, is there a simple way? Oh, okay, so let me go back up a little bit. Rachel asks, are we incapable of opening the modules during the exam? I do not lock down anything. So anything that is just informational would still be open. That includes all the modules, everything that you have turned in on Canvas, all the YouTube videos, all the text channels of past days on Discord. All of that stuff is still open. The only thing I do not allow is collaboration during the exam. I mean, that's the only thing that I really have a problem with. Um, Other than that, you can Google. I mean, for the most part, you can right click on the question and just Google it. Although I'm fairly sure that it won't return anything that's useful, but you're welcome to Google it. Um, all right. To find the signed value of 0111, the two's complement is not going to help you. Two's complement is arithmetic negation, so if you need to do arithmetic negation, that is what's going to help you. But if I don't really see how that is going to help you find the signed value of 0111. You still need to add 1, 2, and 4 in order to get to the 7. Okay, and then Grant has a question coming. Rachel has another one coming. So I'm gonna wait a little bit before I get back to question number 1. Or the third part. The third part is fun too. The sign bit was the leftmost bit. That is correct. Okay, so let's look at 1111. Okay, you're finding the signed value of 1111. Um, I suppose you can use the negation arithmetic negation of the C2 of 1111 because arithmetic negation and C2 really do the same thing and they should cancel out. So when you apply that operation, you end up with the correct value. But then you have to explain to me why you use this technique. Because why do you use this technique for certain cases and not use this technique in other cases? Whereas the formula that we are looking at right now is universally applicable. If you look at this one here, it's universally applicable. I don't see why, you know, I don't see any reason why not to use this formula. Um, and then we have Keaton asking, I'm going to use the circuit I built to do it for me. Well, I won't be able to see your circuit unless you turn it in. So you kind of have to you have to say, okay, I'm using this circuit, to do it, and this is the circuit. But if the circuit, is not explaining how the value is derived, you won't get the points either. Because I need to know that you know why the value is what it is. Because I guess people can just kind of click online and find, okay, what is the signed value of 1111 in binary. Maybe it would just kind of pop up. But that's not what I'm asking for. I'm asking to see whether you can relate the question to material that we have introduced in class and use the knowledge that we have introduced in this class to solve the question, to answer the question. So, Googling, may not be able to help you in that case. All right. Okay, we still have two more people asking questions, but I am going to go back to the question to prepare for part 3. Okay, these have to be really, really long paragraphs. Alright, so Alfred says, so technically we can make a circuit to help as long as we can use text and explain in the circuit why each part works logically. Okay, so if you look at the circuit, just clicking on a multi-bit wire will give you the signed interpretation of those bits. But that doesn't tell you why why the value is the value being displayed on the wire. Does that mean, so I cannot take that as an answer. I have to see how you relate the bits to the explanation that we have talked about in class to give you the points. So 1111 would be negative 2 to the power of 3 plus 2 to the power of 2 plus 2 to the power of 1 plus 2 to the power of 0, and then that sum just adds up to be negative 1. So the plus 7 still needs to be explained. How would I know how 7 fits into 1111 in base 2? I mean, I can see it, but I need you to explain it because I know the answer already, right? I mean, so if you just give me the answer without explaining, that's not going to help. You can flipping all the bits and add one is 2's complement. That is equivalent to an arithmetic negation. That's for Rachel's question. All right. Yes, the gist is to explain it. I need to know how you find the solution, whether you understand the mechanism behind what the question is asking. I don't really care whether you can, whether Google knows the answer or not. I need to know whether you know the answer or not. The circuit knows, then you know the answer, but you may not know why the answer is the answer. That is what I want to know. Do you know why the answer is the answer? It is all about the why. It is not about the what. It is about the why. And to a certain extent, the how. There we go. Yes, I certainly do not make it easy, do I? So that's the second part. The third part is has to do with the borrow look ahead mechanism. So the first part asks, what is the multi-bit p term in this case? All right, so let's go back to the tablet. So you have to remember how the p term is defined. Okay, so that's the first thing. Okay, how are the p terms defined? What is the definition? I mean, I'm really asking you guys, what is p of I? How is p of I defined? For arithmetic, for subtraction, for binary subtraction. That's close, but not no cigar because we are talking about subtraction. So we have to negate x first. That is correct. So we have to negate x and then do a or yi. What about g of I? Um, yes. Okay. So it's without the subscript, it's harder to read the I. It looks like an inverted exclamation point. Um, that is correct. So the negation of xi and yi is how the g term is defined. So in this case, I want to know how the entire p is defined, the entire p term. So the entire p term would be 0 or 0, 0 or 0, and then 1 or 1. So the entire p term as a multi-bit thing is 0, 0, 1 in base 2. The entire g term as a multi-bit thing is going to be 0 and 0. Oh, I take it back. I forgot. I have to negate the first one first. So if I negate the first one first, it's going to be 1, 1, 1 in base 2. And then for g, if I have to negate the first one first, then all of these would give me zeros. So g is going to be 0, 0, 0 in base 2. So I take it back because I forgot to take the negation first. Okay, so if I take the negation first, you can definitely tell that um, with x2, x2 is a 0, so if you negate it, it becomes a 1. Same thing with x1, and then x0 itself is a 1, so when you negate it, it becomes a 0. But because we're using disjunction, it is we can be rescued by y0 because y0 is known to be a 1 to begin with. So that's why p has 1 1 1 in base 2, and then g is negating x and y. So with um, g2 and g1, because we know y2 and y1 are both zeros, so there's no chance they can become a 1. And then for g0, because x0 is a 1, when we negate it, it becomes a 0, so then we also end up with a 0 over here. Alright, so now that we know how p and g turn out to be, okay, so that answers these two parts. P is 1 1 1, g is 0 0 0 in base 2. Spell out the borrowed look-ahead expression of T3 and substitute each P or G bit with the actual value. So what this means is you have to look up the expression for T3. Alright, so that is in one of the modules too. So I'm gonna go look for it. And this is also why it is helpful to have everything, all the definition, all the useful definitions, and in one place to begin with, because you can just go ahead and refer to it instead of having to look it up like what I'm doing right now. All right, so binary subtraction, and it's all the way to the end of the module. Okay, so maybe not this one. So I think it is in the addition. The structure is the same. Same as addition, so we're gonna go back to that one. Alright, so we go back to binary number addition and then go to section 6. I can remember, and then we look up how K3 is defined. Okay, so the way K3 is defined is going to be how T3 is going to be defined, because all we are really doing is just changing how P and G are defined. So we have G2 or P2G1 or P2P1G0. I'm just copying onto the tablet so I can explain that. P2P1P0K0. Okay. Alright, so now we switch back to the tablet. Okay, I just put the T3 equation down here. So now we just put in the values, right? So G of 2 is a 0. Okay, so this is a 0. And then P of 2 is a 1. G of 1 is a 0. P of 2 is a 1. P of 1 is a 1. G of 0 is a 0. These are all ANDed together. And then we have 1, 1, 1, and a 0. So all of these individual conjunctions would give me zeros, and then when we OR all of the conjunctions, we also just end up with a 0 overall, and this is how we can explain T of 3 is a 0, but using the borrowed look-ahead formula. So that answers question number 8. Do we have any questions? I'm looking at the text channel and I'm not seeing any new questions. Or did I miss something? And to answer Jonathan's question, it is not. Subtraction, the way we define P and G in subtraction is not the same as we define in addition. Can I show where G1, G2 is? Alright. This is bit 2, this is bit 1, this is bit 0. 2, 1, 0. And obviously, oh, okay, so let me answer that question first. If we're using t instead of k, isn't it t0? Not sure where I refer to a k0. Oh, right. Okay, you're right. Okay, so I see. That's a t0. That is correct. All right. So are we good so far in terms of how the three parts work for each question? Because for last semester, all 8 questions are structured exactly the same way. So if you know what each section is asking, you just have to do it once, because they're all going to be asking the same thing. So if there are no questions about number 8, we will skip all the way to number 1 in the exam, because that is the hardest one, because you have the fewest number of zeros and ones given, and everything else are all zeros. So now we will handle this challenge. Now you also have to pay attention to the overflow. So in this case, the overflow bit is known to be a 1. That is a huge help already. We also know the L flag is unknown, so we have to find and resolve that one too. So give me a moment here, because I want to copy the question to the tablet, and then we'll go ahead and answer the question on the tablet. So we have question mark 1 1 minus question mark question mark question mark, and then we end up with question mark question mark question mark minus 0 question mark question mark question mark. There's so many question marks, it's funny. And then we end up with question mark question mark question mark. And the most important part is overflow is known to be a 1, and then the L flag is also unknown, so that means it is to be resolved. All right, so let me switch to the tablet. So this is basically the question. Okay, um, the approach to part 2 and part 3 would be identical to question number 8, so it's not really as big of a deal in this question. So the most important part is now we really don't have a whole lot of bits already known. We have 4 bits that are known to be zeros and ones. So we got this one, we got this one, we got this one, and then we got this one. Those are the only ones that we know. And yet, this uniquely identifies all of the other bits. Okay, so there's no flexibility. Okay, everything needs to be a 0 or 1. There's no, maybe this can be a 0 or a 1. Nope, they're already predetermined. All right, so let's go ahead and check out how we can answer this question. So one thing we know is T3 is a 0, right? I mean, it's given. I mean, T3 is this one here. Okay, it is given to be a 0. So what is that going to imply? Well, that implies b of x2 y2 or b of q2 t2 has to be a 0, because that's kind of how T3 is defined. Okay. Okay, so that's not too bad. I mean, it's a constraint. So this means it'll be x2 y2 is a 0, and b q2 k2 also needs to be a 0, because if at least one of these two is a 1, then we end up with a moral of 1. So they both need to be zeros. Okay, but there are a few cases where things can turn out to be zeros, right? So now we have to look at each one, and you say, okay, not x2 y2 is a 0, and not q2 k2 is a 0. All right, so how is that going to help us, right? The hmm? Oh, I keep switching to k. It is t. Thank you, thank you. Oh, this one is a. And there we go. Thank you. All right, so now we look at this and go like, aren't we kind of stuck at this point? Nope, we are not stuck. That is correct. The wedge means logical and. All right, so now so now we might feel that we are stuck, but we are really not stuck, okay? Because we also know overflow is a one, okay? So when overflow is a one, it is given us a great deal of hint, okay? Because the overflow is defined to be what? It's defined to be x2 not y2 not d2 or not x2 y2 d2. I know in the lab it's using a different terminology and stuff like that, but that really is what it boils down to. Okay, it is basically just using the most significant bits of the minuend, the subtrahend, and the difference, and using conjunction, negation, and disjunction, and you kind of combine them into one. And then you guys would be looking at this and go like, well, is this going to help me, right? Because we know this ends up to be a one, so we know this can be a 1 or this can be a 1. They cannot both be 1s, by the way. Okay, we know that they cannot both be 1s. So we know that it is one or the other. So we end up with this scenario, or make this conjunction is giving us a 1, or this conjunction is giving us a 1. So now we can say, okay, pick one, right? And see whether it fits the constraints that we have set up already. What constraints are we talking about? This is a constraint. Okay, we know, we have to meet these constraints. This is also a constraint, but the constraints, they need to be consistent. Okay, so now we say, well, if it is this case, okay, if this is giving us a 1, that means x2 is going to be a 0, y2 is going to be a 1, and then d2 is going to be a 1. And right away, bam, we know this is not going to work because this is conflicts with, I'll call this a here. That conflicts with a. Because if x2 is a 0 and y2 is a 1, that means the negation of x2 and y2 is going to be a 1. But we already know that has to be a 0. Okay, so that means it has to be this one here. So this one implies x2 is a 1, y2 is a 0, and guess what? It even tells us what d2 has to be. d2 has to be a 0 as well. That is cool, isn't it? OV is using, it can be either one. We could use exclusive OR, but usually it is defined as a regular OR. That's to answer Anne Marie's question. All right. So using this, so now we can resolve and go back to the question. So now we resolve multiple bits at exactly the same time, right? Because now we know what this, and this need to be. So we know this has to be a 1, this needs to be a 0, and that also needs to be a 0. So this is a very useful technique, because what we are doing is we are not looking at one single definition or one single equation. We are looking at each equation as a constraint that can limit, okay, what the answer can be, but each equation by itself may not be sufficient to lock down the specific value of a particular bit. But when we look at multiple of them at the same time, when we combine and say, but these constraints have to be consistent, in other words, a solution has to meet all of the constraints at the same time, then we get to resolve the values of the individual bits. All right. So the next bit that we're gonna figure out is gonna be this one here, because the q's are always easy to figure out because the q's are really just dependent on the x and the y. So once you have, okay, I should put it in a slightly different way. Between x, y, and q, anytime you know two of them, you can resolve the third. Okay, it really is that easy. So we know this has to be a 1, and remember what I said? Anytime you know two of the three, you can resolve the third. So this time we know Q, we know D, and we know the 0 is the exclusive OR between this bit, which is already known to be a 1, and this unknown bit. So what do you think this unknown bit has to be? Exactly. Very good. Okay, so all of you are getting this. This has to be a 1. Now what do? We do the same thing, okay? We analyze this particular T2 and we say, we know T2 is a 1, but how can it be, right? So now you use the same kind of reasoning. You say, okay, now we know T2 is a 1, but what does that imply? Well, it implies B of x1, y1 or B of q1, t1 has to be a 1 because that is how T2 is defined. Hmm, I don't really see how that is going to help us, right? Well, it actually does help significantly, okay? Because we know B of x1, y1 is the negation of x1 and y1. And in this case, because we know x1 is a 1 to begin with, the negation of that is going to be a 0. So we already know this cannot contribute a 1. The 1 has to come from the borrow of q1, t1. Okay? Is that okay? And if we know this is a 1, okay, B of q1, t1 is a 1, then we know the negation of q1 and t1 is a 1, which then implies q1 has to be a 0, t1 has to be a 1. Is that okay? Does everybody see how I can now say, I don't really need to know what this bit is at this point, but I know this has to be a 0 and this one has to be a 1. Because that's the only way I can contribute a borrow of 1 over here. Yeah, Jonathan brings up a very good point. I get that a lot. Not only from my students too, is when I explain it, things are, it makes sense. It's easy to follow. It's very logical. And when people have to do it, on their own, it's a different experience. I don't know exactly why, but it does happen more than once. Okay, so now we know, we have 0 and 1 over here. And now that whole column is resolved, okay? Because we know one exclusive OR with something has to give us a 0. So this something here has got to be another 1, okay? And then we have 0 exclusive or 1 given us an unknown. Well, that's just a straight up application of exclusive OR. So 0 exclusive OR with 1 is also just 1. But this is the order, okay? This is the order of how things are resolved. It's not from bit 0 to bit 2. It is actually the other way around. And that has to do with um, we have the borrow bit resolved, and we also have the sign bits resolved on the most significant side first. So that gave us the most information to begin with, and we were able to lock down things because of that. So now we just have to kind of apply the reasoning back to column 0, right? So now it's the same thing. So this is where we can say, oh, refer to that chunk of explanation because it really is identical. Okay, it's identical, that chunk, that whole chunk of reasoning, because we look at this carry of borrow of 0 and we look at x0 starting with a 1. Didn't we get this problem before? That's exactly what happened to bit 1, okay, which we already resolved. So you can now say, okay, we are now in the same scenario as pointing to a circle or another label that you refer back to an earlier point of your explanation, and say we have exactly the same scenario, except instead of bit 1 it is bit 0. And as a result, we can now say chup, 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 and chup. Okay, we can just say, let's just reapply everything, and that ends up to be this. So I know there will be some questions. I'm gonna wait for all the questions to be coming in and take a sip of my gigantic cup of coffee. Alright, so there's a question coming from Matthew. Why did it go from b of x2 y2 plus b of q2 t2 equals to 0 to, because in order for a disjunction to be 0, the individual component of the disjunction also need to be zeros. That is why um, the disjunction itself being a 0 implies each component of the disjunction also has to be a 0. That is a very cool bird. Is it a parakeet?
It's a conure,
Oh, so it's a bigger.
similar to a parakeet,
Okay, that is very
slightly
cool.
bigger.
Slightly. You have a study buddy. And you can collaborate with that.
I'm sure she'll be a huge help.
Oh, yeah. Okay, so Victor's question is why did it go from or to and? The or gave us a 0, and that constraint implies the individual component has to be zeros. And that particular and emphasizes the b of x2 y2 needs to be a 0, and at the same time b of q2 t2 also has to be a 0. And then Omar asks, so if I want to explain how y0 is a 1, you can, it's the entire column. It's not just one single bit. You can basically just say, the condition of bit 0 column is now identical to the condition of bit 1 column, and then refer back to a certain label, when you had things partially resolved, and then just say reapply the same technique, and now we end up with all the values of column 0. Alright, so Yana asks, it might as well get 1 if it sits through the classes. Oh, you mean the bird. Alright, so we still got like 3 or 4 people typing. Alright, so Riley's asks, if the test comes in the form of a Google Doc, does that mean we have to type our reasoning? Yes. So you can type your reasoning, which takes less time than handwriting for most people. Not really sure what is the context of Chris's comment. Of course I rewrite code. Yes, you can write on paper and take a picture. If if you think that is more efficient for you, you can do it that way. And then we have one saying, you do the once you do the first problem, you can copy and paste from your own doc. Yes, you can indeed copy and paste as long as it is from your own document. Um, Oh, okay, I see. So Chris makes a good point. You can basically, use reference points and just say refer to reason, at label blah. Yes, you can use labels and refer to a certain section. Yes, go-tos are allowed in your explanation. You can use labels. Dry. Go to. Yes. or go sub if you're using some really, really primitive form of BASIC as a programming language. All right. Can you check the link to the exam key? Sure. In fact, I can just go ahead and bring that up. Okay, where's my cursor? That is interesting. I can't move my mouse cursor beyond a certain point now. So let me. Hmm. Oh, okay. I see my cursor now. All right. So this is the key to all of the questions, and I believe it is the same as the way I resolved it, except for the L flag. I have not worked on the L flag yet, but the L flag is supposed to be a 1. Oh, the key you linked for a different exam. Is it? Okay. Let me check. Um, oh, you mean the one that I uploaded is. Okay, I see. I see what you mean. Okay, let me reattach that. Alright, so I think this is the correct one. Okay, cool. Alright, so now we actually got at least one interesting value to find the unsigned interpretation of. So let's work on this one. Yeah, it's hard for me to find the mouse cursor because because of the shape that I chose for the mouse cursor. But it is useful for certain applications because it is uh, more precise than the other cursor, and I can see the surrounding. Um, all right, so we now look at 111 in base 2. The value represented by 111 signed is going to be negative 2 to the power of 2 plus 2 to the power of 1 plus 2 to the power of 0, and that ends up to be negative 1. So this is for signed, and then for unsigned, the unsigned value of 111 in base 2 is 2 to the power of 2 plus 2 to the power of 1 plus 2 to the power of 0, and then they add up to 7. That is This is why that sigma notation is helpful, because it really spells out the only difference between signed versus unsigned interpretation. The lower bits, we just add up all of those powers of 2. The most significant bit, one is a subtraction in the signed interpretation, and the other one is an addition in the case of the unsigned interpretation. All right, and then we got some more questions. Will the questions on the test be in a different format? Yes. Reading sigma notation is a puzzle on its own right. No, it doesn't have to be. Okay, so let me give you a way of looking at the sigma notation, and then it really is just a loop. Okay, sigma notation is really just a loop. Um, Although I'm not really sure how far I want to take this analogy, so we'll just go ahead and Um, okay, so we'll instead of using the term sum, I'm going to use sigma. Okay, because that's the Greek notation of sigma. Um, okay, so Omar's way of solving the problem is okay, but you have to fully explain, why you are. Um, but where is that 7 coming from? That's the question. So I'm referring to Omar's screenshot. Where's the 7 coming from? And then I'm looking at Song's screenshot. Okay. That screenshot is not going to be helpful to you at all. It's not going to be helpful at all because we are not at the point of actually writing assembly code, so I'm not really sure why it is relevant. There's no coding. I mean, we are not at the point where we can code at all. And then Omar explains the 7 is the unsigned value that I solve. So you're relating the value of the unsigned interpretation to the signed interpretation. Oh, I see. Okay, because they should add up to an 8 in the case of 3 bits. Okay, there we go. But so you have to kind of explain that part, that with a 3-bit number wheel, okay, the signed plus the unsigned interpretation. I take it back. The subtraction of the signed interpretation from the unsigned interpretation needs to be 2 to the power of the number of bits that we use. So you have to mention all of that stuff, in order for your answer to make sense. There we go. All right, so back to the sigma notation. So the sigma notation, so I'm just gonna say from is where the sigma is coming from, and then 2 is where the sigma terminates. And I'm going to use a pointer to a function here, so that we can be flexible about what we are adding per iteration. So the code here is really that we have a result that we are returning, and result starts with a 0. I suppose I can put the result equals to 0 as a part of the for loop, but it's okay. Okay, so we'll say int. Oh, no, take it back. So now we can start the for loop. So in the for loop, there's no initialization that we need to do. I probably should have put result equals to 0 into the first portion of the for loop. And then to stay in the loop, we want from to be less than or equal to 2. And then for each iteration, we are just adding 1 to from. And then inside the body of the loop, we say result plus equal to apply the function pointed to by f using I as a parameter to it, or not I don't have an I have from. So this saves me from using one local variable, and then return um, result. That's sigma notation. This is equivalent. Okay, this is equivalent to sigma, where I goes from to the 2 value, and then each term that we are adding is f of I. So does that help clarify the sigma notation? Or does it make it worse? Because sometimes my explanation makes things even worse. Okay, very good. So that's basically what sigma is. But because people have questions about the sigma notation, I'm going to guess that people also may have questions about the big V and the big and notation. Okay, so let me locate the module first. Yep, it's right here. Nope, this is the wrong module. Sorry about that. Nope, nope. Where's that module? Nope, not this one. Aha, found it. So this particular notation is kind of the same thing, except the big V is a loop of ors, and then the big kind of wedge or inverted V is a big loop of and. So we are taking the result of a big loop of you know, and then and it with g of I, and then for each of these terms we OR it with the next term. That's what these notations are for. But but it is important to understand this notation. Exactly. So Jonathan is correct. So instead of using addition with the big V, we are doing logical OR. And then with the big wedge, instead of using addition, we are doing logical AND. So it is important to understand this notation. The exam is next Thursday. So this gives you guys, a weekend to study. And as you study, okay, there are a few things you can do. Totally optional. I mean, how you want to study is totally up to you. But as you study, I recommend that you put all the definitions into one list, one place, so it's easy for you to look up the definitions. But it's not just copying the definitions and putting it into one single place. You also have to understand what the definition is saying and also why we have that particular definition for the term in the definition. So all of those are kind of important, but maintaining that list, as you study, as you go through all the modules and all the lectures, can be helpful. Good. Okay, so Jonathan has the right approach. Putting it on the paper. Um, I am not going to give you guys a new lab today. Because we haven't really covered any additional material for floating point number conversion. So you won't have the necessary prerequisite knowledge to do the next lab just yet. So there's no actual lab, which doesn't mean that, I have my. Exactly, you won't get your money back because, instead of using a lab, I am going to use the lab time to be here so that if you guys have questions about the practice exam, I can answer those questions, using the lab time. So, sounds like we have a trade here. You have already paid, yes, and we have already gone past the date of getting a refund. And of course, somebody can ask, I want to talk to the manager then. Ah, my this Starbucks coffee doesn't taste like the Starbucks coffee from yesterday. I want to see the manager. No, floating points will not be in the exam. The exam is excluding floating point numbers, but it will include signed versus unsigned interpretations, as well as comparison of binary numbers. Yes, you can copy and paste from your own document. In fact, you can. Hmm, I'm just trying to think of a way so that you can submit your own document, as an attachment, so that I can see that, oh, okay, this is where you're starting from, which is kind of, which can prove to be interesting to me, is to see the variation of how people take notes and how they prepare a document for the exam. So that can be interesting. Yes, but it's not going to be through Canvas assignment. I suppose that's one way to do it, but if I do it through the Canvas assignment, some people may turn in a file that I cannot open. It's possible that someone in class is still using WordPerfect. Don't laugh. I mean, I should tell myself don't laugh because in a lot of legal or law firms, they're still using WordPerfect for a lot of things. So I might use Google Doc. I really like Google Doc because Google Doc keeps track of edit history, and trust me when I say I have found very interesting editing history when people turn in their answers using Google Docs. And there's no way to turn off that feature, which is the best part. Why is 35% a C? Well, that's easy. Because in the GPA scale, a C is a 2.0 out of a 4.0, which is an A. So that makes a C in the middle of all the scores. Um, but since it has to be a range, right? So there are four ranges. There's five ranges. There's one range for Fs, one range for Ds, one range for C, and so on. So when you plus and minus 12.5% around 50%, then you end up with 37.5% as the lower bound and 62.5% as the upper bound. That is why. I can use this scale only because I grade everything based on the ABCDF scale. So unlike many of your other classes, I don't ask fluffy questions to fill up the first 60%. Is that a good way to explain it? Why I can use this particular scale? There's no 60% to fill up. I just felt that that is unnecessary. Um, I guess it's just a different way of looking at things. Mm, I wouldn't say you're expected to fail. It just means the point values are much more accurately reporting how well people understand the material. That's all. And I have said it in many of my classes. The worst grade someone can get, from a class is not a D or an F. It is a C. I really think people who get a C from a class, they are barely passing, but they may not. It's just going to impact other classes that those people will be taking in the future, and I think that's really kind of the worst thing that can happen. If somebody gets a D or an F, they're going to retake the class. So hopefully, when they retake the class, they'll get all the concepts and they get either an A or a B. A C means they're just barely scraping by in that particular class, and then when people move on to the next class, I think things will not go very well. So that's kind of my view of why a C is really the worst grade to get out of a class. I have had people to asking me to change a grade of C to a D just so that they can retake a class. Okay, Jackie is asking how long is the duration. I'm gonna see if somebody else can answer that question because we have talked about it already. Yes, Keaton, thank you. Um, how to get numbers underlined. Oh, how to get to the number lined question. Okay, this is question number 5. I can do that. Yes, Anne Marie also answered the question correctly, and same with Gerver. But you're forgetting to specify it is Pacific Standard Time, just in case someone says it. But you didn't say. I thought it was Hawaiian time. Yes, thank you. No, it's 5:30, not 5:50. This is why I use military time. There's no confusion between AM and PM. All right. 5:30 a.m. to 6:50 p.m. Um, I have taken exams that are over a weekend. This is in graduate school, so there was a class that I was teaching. It's called program verification, something like that. It's really kind of abstract. The professor gave us the questions on a Thursday, and the exam was collected the next Tuesday. As you can probably imagine, the questions um, were hard enough that a whole bunch of people working secretly together over a weekend would not make a single would not make any difference whatsoever. All right, so somebody asked me about question number 5. So let's go to question number 5 because it is the lab time. So if people want to say, but this is the lab time and we don't have a lab, I want to go, you can go. And I'm still recording. But for those of you who want to kind of follow along with question number 5, we can go ahead and answer question number 5. All right, so let me start a new page on the tablet and then we'll answer question number 5. Okay, so we got question mark 1 minus 0 question mark, and then we got 1 question mark minus 0 question mark 1, and then we got question mark 1 question mark. Overflow is known to be a 0, and then the L flag is known to be a 1. There we go. Oh, is that the wrong question? Alright, so which one do you want me to go over? Yes, it is still being recorded. I just said that. Is there another question that you want me to go over? Maybe question number 2? Because remember, the hardest questions are the low number ones. Okay. All right. So, okay, somebody wants to see question 2. Okay, finally, we have an actual. I have something that's actionable. Okay, that's good. Calculating the flags. Okay, we can try that with question number 2 because question number 2 does require the calculation of all the flags. So that's really handy because it answers multiple questions at the same time. We didn't do number 5. That is correct. But now we are working on question number 2. I'm just copying the question right now and then we'll switch over to the tablet. Minus question mark 0 question mark 1 question mark 0 question mark, and then we have to figure out the overflow flag and also the L flag in this case. Alright, so let's switch to tablet. Alright, so let's work on this one. And you kind of want to work with the most restrictive thing, and the borrow flag is actually very restrictive. Okay, having the borrow flag being a 1 or a 0 usually gives you quite a few constraints about values of the column to the right hand side. So knowing that T3 is a 0 implies that the B between x2, y2, the B between Q2, T2 is a 1. And we know that only one up to one of these two can be a 1, and in this case 1 and only one of these is going to be a 1. So now we have to say, how is that going to help us, right? So the way this is going to help us is, once we expand it, we'll see it. Okay, this is just for expanding, the b function, so that we are using logical operators. Did I say t3 is a 0? No, t3 is a 1 in the question, I think. Yeah, t3 is a 1. It's already given in the question. It is a 1. So if I said it's 0, I misspoke. So I might have misspoken, but it is a 1. T3 is known to be a 1 to begin with. Okay. All right. So once we look at the equations, over here, then we know that if x2 is a 1, okay, so this equals to 1 and x2 known to be a 1 implies that not q2 t2 is the one that has to be a 1. Okay, and the reason is because if x2 is known to be a 1 already, then the negation of x2 is going to be a 0. 0 and whatever is going to be a 0, so this term cannot be contributing a 1 at all. But we know that t3 is a 1 to begin with, so that means the other term of the disjunction has to be the one contributing a 1. So that's how we can lock down that not q2 t2 has to be a 1. But this in return implies that q2 has to be a 0 and t2 has to be a 1, because that is the only way to specify q2 and t2, so that we end up with a 1 when we look at the borrow of q2 t2. So now that we know that, we replace that over here and we put a 0 and then we put a 1 over here. So now that we know all of that stuff, we can infer the value of y2. So because we know 1 exclusive or with y2 is a 0, so the only value that y2 can be is a 1. And also because of the way the D row is defined, D is the exclusive or between the Q and the T. So that means we have just locked down this one as well. And this is now a 1. So alright, so then we have a question of should be explained every time we choose one of two like that. If it is an exact duplicate of a situation that you have already encountered, you can just refer to that one. But if it is not exactly the same, then you have to tell me why you know why a particular bit is a 1 or a 0. Alright, so now that we have locked down this column, which is column 2, we can now work on column 1. So we end up with a 1 here as a borrow. Once again, that's going to help us, right? So now we apply similar reasoning, but it's not exactly the same. So there's no way I can just say, hey, refer to column 2, we have the same scenario. It is not the same scenario. It is similar, but not the same. So now we say t2 equals to the b of x1, y1, or the b of q1, t1. And then we expand it. So this is not x1, y1. This is not q1, t1. Alright. And we know this is a 1, okay, because we determined this bit already. We also know y1 is a 0. So now we say this condition and this condition implies that not q1, t1 is the term that gives us the 1. Because if y1 is a 0 already, which is given, then we know not x1 and y1 has to be a 0. This term has to be a 0. So that means if the OR ends up with a 1, that means this term has to be a 1. So if we know that q1, t1, let me take it back, not q1, t1 is a 1, this implies q1 is a 0, and t1 has to be a 1. So now we resolve these two. Okay, So we got a 0 and a 1 here. So we have something that looks like what we had before. Okay, so the D is easy to resolve. Okay, and you can just say refer to the definition of D, but you have to mention the definition of D at least once, okay, so that you can refer to it. So do not say refer to text module def do not refer do not say refer to the definition in text module. That does not work, okay? You have to mention it and have the definition written at least once in your answers in order for you to refer to that. Okay, so we know the exclusive or between something and 0 is a 0, so that locks down that something to be a 0. There we go. And now we have just the column 0 to work with. So in column 0, we also have we have t1 equals to 1 this time. So now we have t1 equals to 1. So that implies b of x0, y0, or the b of q0, t0 is going to be a 1. But this time we also know one of the bits of bit 0, the column 0. We know t0 this time. Okay, so this expands to not x0 and y0, or not q0 and t0 being a 1. But when we combine the fact that t0 is also given to us as a 0, that implies this term cannot be contributing the 1, so the 1 has to be coming from this term over here. So this is how we can confirm that not x0, y0 is a 1, which then in return implies x0 is a 0 and y0 has to be a 1. So now we resolve these two. We have a 0 and a 1 over here. And then once again, q is the easy one because q is the exclusive or between x and y. So we can now say that refer to the definition of q. We got a 1, and then we refer to the definition of d. We got a 1 in here over here. And then we have to figure out the overflow flag. The overflow flag is x2 not y2 not d2, or not x2 y2 d2. And then you plug in the values, right? So we know x2 is a 1, we know y2 is a 1, we know d2 is also a 1. So this whole evaluation, the whole expression evaluates to 0. Exactly. So I'm reading the text channel. Chris is correct. You just have to label your your explanation, and then later on you can refer to it. And then the L flag is the overflow flag exclusive or with, in this case, D2, which is the sign of the difference. OV itself is a 0, and then D2 itself is a 1, so the exclusive or between those two would also be a 1. So now we have everything resolved. All right. Okay, so Omer is making a point. Why is that implied? Because that's the only way for not q1 and t1 to be a 1. No, we are not multiplying. Those are conjunctions. We have been using that notation for Boolean for a while. Okay, so gotta remember that. Yep, yep. That's actually what the first class talked about, was the alternative expressions that I would use, for conjunctions and disjunctions and negations. So I'm guessing, Omer's question is why do we know not Q1 T1 is a 1? Okay, so let me find that first. Okay, so in the tablet, okay, we know this term is going to be a 0 because y1 is known to be a 0. Because this is y1, y1 is known to be a 0, so this conjunction is guaranteed to be a 0. But yet at the same time, we know t2 is a 1 because that's what we figured out, earlier. So that means the disjunction between these two terms has to be a 1, but we know one side of the disjunction is a 0 already, so the other side of the disjunction has to be a 1. That's how we know not Q1 T1 has to be a 1. Alright, so I think that explains that. So there's a lot of constraints, application here, and and also a lot of understanding of the definitions of the various bits. Yep, this is still recording. It does make the overall recording really long. So, if you have been putting down time marks, like at this time, Tech is talking about this portion of this question and so on, that would definitely help you get to the right point really fast. It's not about how many times over the weekend, it is about how much you get out of it, you know, as a total. So what I would do, if I were to, you know, if I were to take a class in college where the professor is actually recording everything, I would just use the pause button a lot. Okay, I would just play a sentence or two, okay, getting to the point where I go like, okay, I'm not really quite sure why that is the case. Then I just pause it. Okay, I will pause it. I will put some time to think about it, and if I can't really explain it or if I cannot figure it out, I'll go back. I'll just reverse. Okay, so instead of watching the whole thing, from start to finish and then watch it again from start to finish, I'm just going to pause a lot and then go back a little bit, replay a little bit, pause again, think, jot down my own notes until I feel comfortable that I really understand why things are the way it is explained. Until I fully until I fully understand the explanation, then I move forward. Yeah, you can use 2x speed. You can also download the YouTube, and you guys know all the extensions, to download YouTube recordings. So you can have it on your own hard drive. You can do whatever you want. You can do your own special edition, right? I mean, you can add music to it. You can replace my face with something else. Yeah, that's kind of the point that I'm making, Grant. It's not about how many times you watch it. Um, this is a really difficult thing for me to explain. I have I have this when I don't fully understand something, I have this kind of gnawing, feeling inside that I'm not fully understanding something. And when that happens, I would just kind of stop and then go back to the more elemental definitions and then try to reason out everything. Um, so that's kind of it's really hard for me to explain that sensation because I think there are some people without this sensation. It could be a trained thing, it could be an inborn thing. I don't know exactly what it is, but without this sensation, some people think that if they can regurgitate, if they can memorize things, that they are quote unquote understanding a concept. But that really is not the case. There you go. YouTube DL for download. That I had a stroke. Well, that day may come. Yeah, remember, understanding is about connecting the concepts. It is not about memorizing the concepts. It's about making connections in your head between the concepts. And that really is the most difficult part of teaching. Is it's not about teaching the knowledge, it's not about demonstrating how I would solve a problem. It is about, how do I know that you guys, understand the concepts? How do I know that you have made the connections? Okay, I'm just reading the text channel, so I'm guessing it is okay for me to turn off streaming at this point. Oh, number 5. Okay, sure. So we'll go ahead and work with number 5. And I had that set up in the previous page too on the tablet. Let me go back to the previous page. There we go. I believe this is question number 5. Noor, do you want to confirm whether what you're seeing on the tablet is number 5? All right, I'm not seeing anything. Okay, thank you. All right, so once again, the most the one bit, okay, that contains the most information, overflow is one, and then the other one would be the borrow bits, okay, because those two are fairly long expressions, and the longer the expression, the more information it is giving you once we know the value of the long expression. So we'll start with the overflow. Okay, so the overflow is x2 not y2 not d2, or not x2 y2 d2. Okay, and we know it is a 0. Okay, so we can try to find out, okay, can this be telling us something? Can we lock down anything from just knowing overflow is a 0? We can rule out something. Okay, the only thing we can rule out is we do not have a 1 here, and we do not have a 0 over here. I should say, let me put it more carefully. We know that um, x2 cannot be a 1 and d2 cannot be a 0 at the same time. Okay, so it's still possible one of them, it's still possible this is a 1 and then this one is a 1. It is still possible that this is a 0, but then this one has to be a 1. But there can also be other cases as well. So in this particular case, the overflow bit being a 0 doesn't tell us much. The overflow bit being a 1 tells us a whole lot more than when it is a 0, because there are 6 ways for the overflow bit to be a 0 and only 2 ways for it to be a 1. And that's why when the overflow is a 1, it is helping, it's putting a lot of constraints on all of the other bits. X2 and D2 can also be the same. Yes, they can be the same. Yes. Alright, so if that is not helping us, let's look at T3. So T3 is, I'm just doing a shorthand now. So it is the negation of x2 and y2, or the negation of q2 and t2, and we know it is a 0. Alright, so this is actually quite helpful, because we already know that y2 is a 0, so we're looking at not x2 0, or, and then we also know that q2 is a 1. This really, okay, let me back up just a little bit here. We can resolve x2 without using the tricks that of using the borrow, because we know whatever is exclusive or with 0 is a 1, so that automatically means this is a 1. Okay, well, I shouldn't say automatic, but it's simpler to figure out this 1 here, because we know x exclusive or y becomes q. So if you know any 2 of the 3 values, you can resolve the third one. Okay, so that's what I said earlier. So now the question is, what is this going to be? You mean this bit over here? And this is where the overflow comes in handy. Okay, so now we can say we can substitute the values into here. So we now know that x2 is a 1, y2 is a 0. Okay, and x2 is a 1, y2 is a 0. So we know this side here has to be a 0, okay? Because just because x2 is a 1, not x2 is going to be a 0, it is a part of a conjunction, so this entire conjunction is going to be a 0. Now let's look at the other side, okay? At this point, because we know x2 is a 1, okay, plug that 1 here, everything is looking okay. It's possible this conjunction can be a 1. And then we plug in y2 is a 0 into here, but because we have to take a negation of y2 before we put it into the conjunction, so this is also going to be a 1. So at this point we have 1 and 1. So that means we only got one more bit to make this not 1, because we know overflow is given to us as a 0. So that means not d2, okay, so this whole thing implies that not d2 has to be a 0, because otherwise we would have ended up with overflow being a 1. And if not d2 is a 0, so that means d2 has to be a 1. That is how we resolve this guy over here, has to be a 1. And now we can kind of go back and say, okay, but we know this one is the exclusive OR between this one and this unknown term here. But there's only one way you can say one exclusive OR with something being a 1, meaning this has to be a 0. And L is a 1. Oh, yes. I didn't see that. I forgot about the L flag. Very okay. That's very good. Good observation there. Yes, because this one is directly linked to this one over here. It is exactly the same thing. Good job. You guys are paying attention better than I am. All right. So now what do we know? Well, we know. So now we know that T2 is a 0, and we know this 0 is not x1 y1 or not q1 t1. Okay, that's one thing we know. Okay, we know this or is a 0. But we have a little bit more constraint than that too. We know d1 is a 1. Okay, so because it's given. Okay, d1 is a 1 is a given. So this means, okay, it implies that Q1 and T1 cannot be the same. They have to be opposites of each other. So this implies Q1 does not equal to T1. But then there are only two ways that they can be different, right? Okay, so this implies Q1 is a 0 and T1 is a 1, or okay, I'm mixing the symbols, so let's not do that. Or Q1 is a 1 and T1 is a 0, because there are only two ways that Q1 and T1 are different. Okay, because if one is a 0, the other one has to be a 1, and then vice versa. Okay, but we know one of them is not possible, because if this is the 1, then we would have ended up with a borrow as T2. Okay, so we can say this would have caused T2 being a 1. So now we can say this has to be a 1. Okay, so that locks down Q1 being a 1 and T1 being a 0 here. Okay, I'm not sure how many of you are still following me, but assuming you are following me, this is how we get to resolve these two values. But then we still have to resolve these two values. It's the same reasoning. So this is where you can apply similar reasoning. Okay, you can say, well, we know this subtraction does not give us a borrow of 1, and yet the exclusive OR between these two gives us a 1. So that means they have to be opposite. One has to be a 1, the other one has to be a 0. But 1 minus 0 is the only case where we do not end up with a borrow of 0. So you can now say, yep, we end up with just minus 1 minus 0 over there too. Cool. Now we just have one more column to resolve and we are done with this one too. So now we know there's no overall borrow. I'm just looking at this and see if I can do this without any. Nah, let's just do the proper reasoning. So t1 being a 0 implies not x0 y0 or not q0 t0 is a 0. Okay, that's just how it's defined. And we know this is a 1, so we have a not 1 y1 or not q0 1 equals to 0. And because this term is going to be a 0, so we know that cannot be the one contributing a term. Okay, so we know that this implies that q0 has to be a 0, right? Because q0 being a 0 means the negation of that is a 1. Then only, oh no, I take it back. I take that back. Sorry. I, I, I I forgot that we wanted the OR to end up with a 0, so I forgot about that. So this side is guaranteed to be a 0. Okay, so it's not a problem. We also want this term to be a 0, so the only way for not q0 and true to give us a 0 is for q0 to be a 1. So now we know q0 is a 1, and that locks down y0 to be a 0. And then we have 1 minus 1, which is going to be a 0 down here. Okay, so Noor asked why is it y1? Regardless of what y1 is, it would not have it would contribute a borrow of 0. So y1 is not immediately resolvable. Instead, it is q0 that is immediately resolvable. How I got g1 and that's q1 and t1. We got q1 and t1 because of this, right? Because we know that they have to be different, and 1 would have contributed a 1 to t2, and that cannot be the case because t2 is known to be 0, so it has to be the other one. That's how we figure out q1 and t1. Yeah, it's kind of like binary Sudoku with special rules, right? I mean, other constraint based games include crossword puzzles, so they're not as those are more about memory and vocabulary than anything else, but it is still constraint based because as you fill in the crossword puzzles, you would have locked down certain letters, so that limits what word you can use once you figure out something already. Um, okay, so don't they have to be opposites? Which two have to be opposites? We don't know anything about y0 because there's no way x0. I'm not really sure what that means. If q1 not t1, but the borrow function negates q1 and then and t1. We do not negate t1. I don't understand why we are negating t1. Okay. That is true. Not both can be true at the same time. That has to do with how Q is defined by the exclusive or between X and Y. They can both be false. Yeah, they can totally both be false. Because if they cannot both be false, then we cannot possibly end up with these borrowed bits being zeros. Because if they are not both false, then the OR is going to be true. Then we cannot end up with these T1, T2, and T3 being zeros here. Hmm. Yep. All right. So it looks like we got all of the questions answered. Um, and instead of leaving the tape, quote unquote, tape running, yes, I think 10 years from now, nobody would understand me at all if I say, "Well, I don't want to leave the tape running." What tape are you talking about? So I think I can turn off streaming at this point. I will still be looking at the text. I will still be paying attention at the text channel. So if you guys have a question, go ahead and post the questions. But I don't think we have a continuous stream of questions that requires interaction anymore. So I can probably turn off streaming. If somebody objects and say I want to keep streaming, I can think about that. But there doesn't seem to be a need at this point. Yeah. So on Tuesday, it's somewhat up to you guys. So I want you guys to be studying. Oh, sorry, I couldn't hear you. Go ahead. Oh, okay. So,
You're hearing his voice echo back, so.
all right. So on Tuesday, so I think it will be helpful if you guys can kind of study over the weekend because we do have 5 days before Tuesday. So if you can spend those 5 days, studying, collecting all the definitions together, trying to make connections, between all those concepts, and then work on the sample question that I have posted here, because I really don't think anyone can actually memorize my solution. And if that is the case, that means people can always kind of go back to question number one or two or three, because I didn't actually work on question number three, to work on those. And then on Tuesday, Tuesday is a good time to ask questions. So as you study and you say, okay, I got this, but I'm not really sure about this. So you jot down the questions, and I will try my best to answer those questions on Tuesday. In the absence of questions on Tuesday, what I'll do is I'm just going to continue with the floating point number stuff, um, and then we'll have a lab on Tuesday, related to the floating point number stuff. So hopefully people will have questions related to the exam on Thursday, so that way we can kind of stay on that track a little bit at least on Tuesday, and then we'll kind of use the leftover time to continue the discussion of floating point numbers.
Thank you.
Sure, you're welcome. Alrighty. All right, so I'm gonna turn off the voice channel on Discord, and also get rid of the streaming at this point, because I don't think there's a constant stream of questions anymore, and I'm not demonstrating. So I'm gonna turn it off. And if you guys are signing off, go ahead and have a nice weekend. It's kind of long, and use this time to kind of study and prepare your own notes for the exam. That would be a good use of the time over the weekend. So I'm going to turn off the voice channel now.